actually you can run this function. And the other interesting topic is how to evaluate matrix equations. So we must know what is a matrix equation. Actually, in the first assignment, I asked you to find what is the exponential of a matrix. And I have to explain that you can use a function like this to find the exponential. In control or in differential equation solution, we know that if we have a differential equation like this, the analytical solution is something like this. So this part requires you to know how to find the exponential function, which is also called state transition matrix. It is a matrix function, how to find it. And in this part, I will explain how to find the matrix exponentials and triangular functions, and also a very useful function I raised myself, which enable you to evaluate very complicated Matlab matrix functions. For matrix exponential of e to the power of a, where a is the matrix, there are quite a lot of numerical methods, and in the survey paper, and Professor Moller listed the 19 methods. There are lots more methods now. It is listed in 1979, and now there could be much more methods algorithm which can be used to find a to the power e to the power of a. And in Matlab, we can use extma to find the exponential. And this function can also be used for symbolic matrix A. And also to this form, a to the at, exponential of at, it can also be used. Suppose we have a matrix like this, and this is a Jordan matrix blocks, and this one is called the Jordan matrix. And how can we find e to the power of a, and also e to the power of at? Apart from this, how can we find the log a? To solve these problems, we have to enter a matrix first, and then call the expm function. And there are differences. I have explained the exp function earlier. And here we have expm function. The difference between them is, for exp function, it is an element-by-element manipulation of the function, and this one is the matrix function. So they are different. And there are other functions. For instance, we have log function, and here we have log m function for form log to calculate log a. They always have an m symbol after the function name, and we can use log m to find the log value of log function of b, which should be the same as original function a. And we can take the difference between them. So these are the numerical solutions. First, find exponential function of a, and then take the log value to the result, and it should return a. And we now take the error between these two matrices, A and C. The error should be 0. And so this is the result we get. The error is 10 to the minus 15. It is a very small number. There is a very small error there. So we say that both of the functions works well. Both of B and C, ESTM and log n function work well. Now the question is how to find in an analytical way e to the power of at, where t is a symbolic variable. To solve the problem, what we need to do is to declare t as a symbolic variable and then code the function. And this is the result of the family n. So it can be seen that ESTM function is very powerful. It can be used to find this kind of computation easily. And there are other examples I will not demonstrate. So with the use of ESTM, we can easily find the analytical solution or numerical solution of a given matrix or AT, E of AT. So how can we find the sign A or sign AT? You can find sign AT using a function FUNN A, and you can code the sign here. You can find the sign function. If you code the cosine there, you can find the cosine function. This is a numerical way to solve the problem. However, you cannot find sin AT there. You use the numerical function. So let's see how can we find the sine function. There is no problem with the use of sine function there. You can easily code the function m, a, and sine. You can find the result. And also, if you are trying to find the function, you can also use Taylor series expansion. However, due to the experience you have done earlier in your assignment, you may notice that this algorithm may not always work. So just ignore this part. We will concentrate on the solution of this part. Now let's consider the famous Euler function, or Euler formula. For e to the power of JA, we have this formula. And for e to the power of minus JA, we have this formula. We add them together, and this term will be cancelled. And we can finally find the cosine function from the exponential functions. And if we minus this formula from this one, we will consider the cosine terms and finally find the sine terms. This is the standard way to find the sine and cosine functions. And it should be addressed that these formulas also hold for matrices A. So in this way, we can use ESTM function to find the sine function or cosine function. And also the ESTM function can be used to solve e to the power of AT. So we say that with the use of these functions, we can easily find the sine AT and the cosine AT given.